Okay, welcome back to this video, guys. Today we're going to be looking at probability, and our learning goal for this one is that students can determine complementary events and calculate the sum of probabilities. Okay, so at the end of this one you'll want to be able to calculate the probability of an event and its complementary, calculate the sum of probabilities, and to use probability to solve complex problems. Okay, what is the likelihood? So probability addresses that issue of how likely is something to happen. Okay, and so let's say, just for instance, we'll say how likely to shoot paper into the bin. Okay, let's say that 10 goes at it. Okay, so you are throwing stuff into the bin. It's just in front of us there. And let's say that after that 10 goes, Mr. Brady gets 2 of them in and Claire gets 8. Okay, now on the basis of this, let's just say you weren't there, you heard about it later, everyone was laughing about it, how terrible Mr. Brady was at throwing paper into the bin, and they were like, well, the national paper throwing competition is coming up. Who should we pick? Should we pick Mr. Brady or should we pick Claire? And, you know, there might be some other extra issues, like you might think, well, Mr. Brady is a pretty cool guy, maybe we should get him to come, but Claire is way more likely to actually throw the paper into the bin than Mr. Brady is. And so you'd say, from a probability point of view, that you would definitely choose Claire to go on the team because she's way better at throwing paper into the bin. Now, there are there's a movie that came out recently with Brad Pitt in it called Moneyball, where it was about him as a baseball team manager, where he purely chose the team based on statistics and probabilities rather than sort of other issues, and just let the mathematics speak for itself. And it was highly successful and sort of brought into the forefront of your imagination that idea of, can we just trust the maths or is there other things that are going on? So obviously in this case you'd certainly choose Claire because apparently I'm terrible at throwing stuff into the bin. Okay, so probability addresses that, how likely is something to happen. Okay, some key ideas for us. So we've got some definitions and stuff first because we need to make sure we're all sort of on the same page with what we're talking about. So a trial is the thing that is being done. Okay, and so for example, it might be tossing a coin. Okay, so a toss of a coin or a throw of a paper into the bin, that is the trial. That is the thing that is being done. Okay, now outcome is what occurred. Can't remember if it's a double R. Let's just go with one. So what occurred? Okay, during the trial. Okay, so that might be, for instance, so the outcome of tossing a coin is you can either get heads or you can get tails. Okay, so an outcome is what occurred. Hang on, sorry. Silly. This is what can occur. What can occur from a trial. Okay, so we can toss a coin and the two possibilities are heads and tails. Sorry about that. Okay, an event, however, is what did happen. Okay, or what you want So, or what you are investigating. Okay. So, for instance, you could have the probability of tossing a heads. Okay, so that would be the event. The event is the probability of heads turning up when you toss the coin. Okay, so it's there's not a big difference between outcome and event, but is that just that issue of like what's the possibilities and what is the thing that you do actually want to happen, or what did actually happen. Okay, right. Because this is all called theoretical probability, what we're looking at the moment, which is that issue of like we're just purely going on the theory of what's probably going to happen rather than actually carrying an experiment out. Okay, the sample space is the set of all possible outcomes. All possible outcomes. Okay, sample space is the set of all possible outcomes. So this is how we write that. So let's say we are rolling a 6-sided die. Okay, the sample space for that we would write as S equals, we get to write the funny curly brackets because curly brackets tell us this as a set happening, and we list all the possible outcomes. So if we rolled our 6-sided die, we can either get 1, 2, 3, 4, 5, or 6. Okay? So now let's look at the complement of an event. So let's say that we were looking for, let's say we're rolling a 6-sided die, and if rolling an even number, okay, so the event is that we roll an even number. So the complement of that is that we roll an odd number. Okay, or we could say roll not an even number. Okay, so there's a couple of ways to do it. Either you can look at it as roll an odd number or roll not an even number. Okay, so that's our idea with complements. So we denote our complements with a little dash. So for instance, if we had the probability of rolling a 6 on our die, that's our event, is the rolling a 6. So if we're going to write probability of not rolling a 6, we would write probability 6 with a little dash here. That means the complement of something, the opposite of something. Okay? Or not necessarily opposite, more so what makes the rest of what's there to make up the whole. Okay? Remember with complementary angles, they were what you needed to make up to become a 90-degree angle? Maybe. Okay. Right, let's look at how we can calculate the probability of an event occurring. So, this is the formula that I want to see turn up in your workbooks and stuff. So, we have probability of some event, okay, is equal to the number of favorable outcomes. I might just write favorable outcomes divided by the number of total outcomes. Okay, now, so that you don't have to write that out all the time, all I want to see in your books is, for instance, that PR of the event is equal to fav over tot. Okay, favorable over total. Okay, I think that that's pretty fair, rather than having to see that, because I want to see this formula has to turn up all the time. Okay, PR event equals fav over tot. Okay, so let's say we are doing the probability of rolling a 2 or a 3 on a die And so we would write that that's favourable over total. And so that's going to be equal how many times in a die do we get 2 or 3? It's 2 of them. Total number is 6. And so that means that we're going to get 2 over 6 can be rewritten as a third. And so that means that we could write that as 33.3% chance. Okay, so there's a lot of different ways that you can write your probabilities. As fractions, as percentages, as decimals, it doesn't really matter. Okay. Now, lastly and importantly, the sum of probabilities from the trial is 1. Okay, so for our, remember that you might have seen last year that idea that on a continuum like this, we will have, so if probability is 0, and 1. So 0 is impossible, and this is certain, and so in the middle you have sort of like your even chance. That's at 0.5, and then around about here-ish at 25% and 75%, you might have your unlikely and likelies. Okay. And so our events will sort of add up to be that. So let's say that our event was to get, let's get our rolling 0, a 2 or a 3 on our die. So that was a third for the first, for what we looked. So that was our probability of getting a 2 or a 3. So that means that the probability of not getting a 2 or a 3 here, so 1, 4, 5, and 6, and it makes up the rest of it. Okay, so all of the probabilities from a trial will all add up to 1. We can't have greater than 1 probability, okay? And we can't have less than 0 either, okay? So, sorry this is a bit of a longer video, but I'm sort of trying to smash all the probability stuff into one hit. And you'll have plenty of chance to practice it and start to interpret, understand what we mean by probability and how we use it. Okay, thank you.